Hey, and welcome to AP problem number 12. This one has to do with bonding. So the first question says, in the boxes provided, complete the Lewis structure diagram for each of the three molecules. So the first molecule is CF4. So carbon is the center atom because it is the least electronegative, as fluorine is the most. So, four fluorine atoms, they bond to the outside with single bonds, leaving three lone pairs, so six valence electrons. For PF5, if we refer to the periodic table here, P is in the third row, so it can handle more than the standard octet rule. So it can hold 5 of the fluorines, and each of those fluorines have single bonds and 3 lone pairs also, which means 6 in the valence. For SF4, as we look back on the periodic table, S is also in the third row, so it can handle extra. And sulfur is also an exception because since the d orbital can hold in more, it keeps the lone pair there. So it is single bonded with the 4 fluorines around, with the valence of 6 and 3 lone pairs, and then sulfur also has a lone pair, and that affects its shape, which we'll get to in a bit. So letter B asks, what is the fluorine-carbon-fluorine bond angle in CF4? And since there are 4 effective bonds to the center atom and no lone pairs, it is in a tetrahedral shape. So that means the bond angles are at 109.5. You would think, just based on this 2D image, that they're at 90, but since it's 3D, it can go in more than one angle, therefore making it more than 90 at around 109. Sorry, the allergies. The next one is, what is the hybridization of valence orbitals of P in PF5? So P is the center atom here, and since there's 5 effective pairs it has, if we refer to the notes we got, if you have 5 effective pairs, it is a DSP3. So that is the hybridization for phosphorus in this case. So as I said about how sulfur having that lone pair off of it affects its geometry, it would become a seesaw. Normally you'd think, oh, there's only 4 bonds, it's tetrahedral, but since there's this lone pair, it creates a seesaw geometric shape. Yeah, because it would throw off the bond angles. It would pretty much have the same angles as this, but with a lone pair instead of a bond. So now we get on to C, and this one has 2 drawings, or 2 resonance structures or not resonance structures, just 2 structures for OPF3, shown below. And the first one is, how many sigma bonds and pi bonds are in structure number 1? So a sigma bond is a single bond. So there are 1, 2, 3 single bonds that you can see. However, a sigma bond also accounts for a double bond. So there's 1 in the double bond. So you have 4 sigma bonds. A pi bond is a multiple bond. So if it's a 2 or a 3, that counts as a pi bond. So since there's a double, it's 1 pi bond. So you have 4 sigma, 1 pi. And to find which ones are best represented, as asked in 2i or AI, you have to take the normal number of valence it has. So in this case, oxygen has 6 valence electrons normally, fluorine has 7, and phosphorus with 5. So you take the 6, because that's the normal one it has, and then you take the bond. So each bond counts as 1, so you subtract by 2, and then you also count the valence electrons it has. So there's 4 valence. So in this case, it's 6 minus 2 minus 4, which gets you 0. For fluorine, it normally has 7, and there's 1 bond and 6 valence electrons. So it's 7 minus 1 minus 6, which gets you 0. For phosphorus, since it's the center atom, you don't have to worry about valence electrons because it shouldn't have any, unless it's in sulfur's case, in which it would have 2. But the phosphorus doesn't have any, so you just count up the bonds. So there's 1, 2, 3, 4, 5, because that's 2. So it's 5 minus 5 will get you 0. And you want to be as close to 0 as you can, that's the most right. As you look on this side, this one's not right because if we look at oxygen, it's normally has 6 valence electrons. In this case, there's the 1 bond and there's 6 valence on the oxygen, so that would get you -1. For fluorine, it stays the same because if we look here, the fluorine bonds are still the same. There's one, it's a single bond, and then 6 valences, so it'd be 7 minus 1 minus 6 will still get you 0. But phosphorus, in this case, there's only 4 bonds going to it, so it would only have 4 atoms, so it would be 5 minus 4, which gets you 1. So in this case, structure 1 is better than structure 2 because structure 1, they all go to 0. And that wraps up this one. Thank you.